Hi, future doctors. Welcome to the next class. In this class, we will discuss about measurements, errors, and measurements. So, what is meant by error? We will call means generally the uncertainty in the measurement. We are calling it as error. So, what is this uncertainty? So, why we are calling it as uncertainty? So, in this, if you wanted to measure by taking a scale which is having only, which is calibrated or divided into centimeters. Here, divisions are dividing between 0 and 1, only one division is there. So, another scale if you are taking, so between 0 and 1, how many divisions are there means? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Between 0 and 1, 10 divisions are there. Now, if I wanted to measure length of an object, I have to place that object on the scale. Now, I place like this one object. Now, 1 is correct because it is going to cross 1. But here, between 1 and 2, I am taking it as 1.5. Therefore, length of the object is 1.5 centimeters. So, here 1 is correct, but this one is going to be assumed by us because it is in between. Next, the same object if you place here, same object I am placing on this scale. At the time, we are getting object in between 1.5 and 1.6. In between 1.5 and 1.6 means I will take 1.55 centimeters. Now, it is 1.5 is clear, but this is going to be assumed. This is only we are calling it as uncertainty in the measurement, isn't it? So then, to get accurate value or true value, what we will do means we will take by using these devices different times, number of times will increase. If you are going to calculate length of an object, L1 is equal to 2 centimeters, L2 is equal to 3 centimeters. Then what is the true value of this means? Average value. That is only true value. Just for convenience, I am taking only two values, 2 plus 3 by 2. This is nothing but 5 by 2. So 2.5 centimeters is the true value. Now, what is the error in 2 centimeters? Error is going to be represented by like this. Delta L1 is equal to true value minus measured value. That is 2.5 minus 0.5. This is only going to be represented length of an object L1 is equal to L1 plus R minus delta L1. What is delta L1 here? Absolute error. L1 is measured value. Now, what is the ratio of delta L1 by L1? So, delta L1 by L1 is nothing but relative error. If you multiply this one with 100, then this is called percentage error. Only delta L1 by L1, we are calling it as relative error. If you multiply relative error with 100, that is only percentage error we are going to say. So, if you want to measure two values, so this is delta L1 is absolute error in L1. Like that you can calculate absolute error in 3 also. How we will represent these in generally? A is equal to A plus R minus delta A. B is equal to B plus R minus delta. Now, what is delta A means? Absolute error in A. What is A means? Measured value. B, measured value. Delta B, absolute error in B. If you are adding these two, if C is equal to A plus B, then how we are going to add means delta C we want. Delta C is going to be written as delta A plus delta B. Then C will be represented as C plus R minus delta C. What is C means here? A plus B. What is delta C means here? Delta A plus delta B for addition. If you want to do C is equal to A minus B, what we have to do means again delta C is going to be, we will write errors cannot be subtracted, absolute errors, therefore we will write delta A plus delta B. Then again C will be represented like this one. But in place of delta C, we have to write delta A plus delta B. Means in case of subtraction, in case of addition, absolute errors always will be added. So if you multiply those, what you are going to do? So if you multiply C is equal to AB or C is equal to A by B, you are multiplying and dividing. How we will write C plus or minus delta C? Now C is going to be AB. Then what is delta C? Delta C is nothing but delta C by C is equal to delta A by A plus delta B by B. Now delta C is going to be equal to C into delta A by A plus delta B by B for both multiplication and division. For multiplication C we will write AB. For division we will write C as A by B. Now we will see one example problem on this, then you will get understood. But to see those problems, we require some basics, that is nothing but significant digits and rules for addition and subtraction and multiplication. So what are significant digits? How we will take from numbers. Significant digits or significant figures. For this, with the numbers we are going to follow the rules. So if you are taking 1, 2, 3, 4, 1.234, 12.34, 123.4. So all are non-zero digits. All non-zero digits irrespective of decimal place are significant. Therefore, among all these, how many significant digits are there means 4 significant digits. Whenever a problem will be coming means only zeros are coming or decimal places on numbers less than 1. So 0.020. 1. Now, for this, what is the rule means? 0 in between two non-zeros, irrespective of decimal place, are always significant. Therefore, this 0 is significant. These zeros are not significant. Therefore, in this total significant digits, 3. So, same number we are taking like this, 0, 2, 0, 1, 0. At the time, 0 followed by last non-zero digit after decimal place are significant. This is already in between two non-zeros. Therefore, in this 4 significant digits, these zeros are not significant. If you are taking only pure number 5000, 50, 2100, so there is no decimal place, these zeros are not significant. One significant digit, one significant digits in these 2 significant digits, isn't it? Next, for exponential numbers, 2.3 into 10 power 10 or 6.023 into 10 power 23. Even if it is plus or minus 10 powers are there, we will take significant digits in this 2, in this 4. This 0 is in between 6 and 2. So, these are about significant digits. We will follow these for rounding of numbers. Whenever you are rounding of numbers, so 0.2375. So how many significant digits are there means 4. Round this number up to 2 significant digits. Then 7 you have to remove. Whenever you are removing 7, so removing digit is going to be greater than 5 or less than 5, you have to take care. So if removing digit is greater than 5, 7 is greater than 5, then preceding digit should be raised by 1. So round this number up to 1 significant digit. Then removing digit is 3. 3 is less than 5. Therefore, it remains same. Isn't it? So same number, round this number up to 3 significant digits. Then this is 5. So before 5, even is there, odd is there, you have to take care. This is odd number. If odd number is there, it should be raised by 1. If even number is there, it should be remaining same. 2, 6, 5 they gave. So 6 is even number, then 0.26. But 0.2652 is there, 0.2753 is there. So after 5, if any number is there, then this preceding digit should be raised by 1, even if it is even or odd. Generally, we will take like this. This is about rounding of significant digits. Next, following the rules for addition and subtraction. So 2.3 plus 4.14. If you add these two according to significant digits or subtract these two according to significant digit. For both addition and subtraction, you have to follow decimal places. Which is least decimal place? In this 3, in this 2. Therefore, 1 decimal place, 2 decimal places. Therefore, final answer should be in how many decimal places? 1 decimal place. 2 plus 4, 6. 3 plus 1, 4. 6.44. This is not correct answer according to significant digits. Final answer should have 1 decimal place. 4 you have to remove. 4 is less than 5. Final answer is 6.4. Like that for multiplication and division. 1.1 into 3.14. Final answer should have least significant digits. After multiplying, let us assume. After multiplying these two, how much you are getting, you can cross check. 3.454. 454, but in this 4 significant digits are there. You have to follow least significant digits. Therefore, final answer should have 2 significant digits. 5. 5 is having some numbers, therefore 3.5. We are going to take like this. So, blindly we can follow addition, subtraction, we will follow decimal places, least decimal places. For multiplication and division, we have to follow least significant digits among the given numbers. Now, see those how we are going to do calculations. If A is equal to 20 plus or minus 0.2, B is equal to 10 plus or minus 0.1. So, find A plus B. If C is equal to A plus B, 10 plus 20, that is going to be 30. So, then what is delta C? Delta A plus delta B, 0.2 plus 0.1, 0.3. Then how we are going to write C? C plus or minus delta C. So, 30 plus or minus 0.3. Isn't it? How we will find relative error? So, delta C by C, 0.3 by 30. So, 3 will be cancelled here. 1 time 0.1 by 10, 0.01. Percentage error. Delta C by C into 100. 0.01 into 100, that is 1%. So, if they wanted to find C is equal to A minus B, then how is the answer will be means 20 minus 10. This is C. Then how we will write C plus or minus delta C means 20 minus 10 is 10. 10 plus or minus. What is delta C means? Delta C will be same answer because we will always add. Now what is relative error? Delta C by C is 0.3 by 10, 0.03. What is percentage error? Delta C by C into 100, 0.03 into 100, that is going to be 3%. This is for addition, subtraction. If they give division or multiplication, C is equal to A by B. What is A by B here? 20 by 10. That is going to be 2. Now, what is delta C? Delta C by C is delta A by A plus delta B by B. So, delta C by what is C you got here? 2. Now, what is delta A here? 0.2. So, 0.2 by 20 plus 0.1 by 10. So, this value is going to be cancelled one time. So, 0.1 by 10 plus 0.1 by 10. Therefore, 0.2 by 10. Delta C by 2. Then what is delta C? So, this 2 will be cancelled here 5 times. So, 0.04. Correct? So, 0.04. Now, C can be represented as C plus or minus delta C. Now, what is C value? 2 plus or minus 0.04. If they are asking multiplication, A into B, then 20 into 10, that is going to be 200. So, for this, in place of C, same answer you are going to get, but in place of C, how much we have to take? 200. So, if you are taking 200, right side you are going to get same answer. What you got here? 0.2 by 10. If you do like this, same answer, 0.2 by 10 we are going to get. Now, 1 0 will be cancelled. Now, delta C is 20 into 0.2. So, delta C is 2 into 2, 4. Now, for this how we are going to do? C plus or minus delta C. Now, what is C you got here? 200 plus or minus 4. So relative error 4 by 200 delta C by C, percentage error delta C by C into 100. You can calculate those. In this also you can do same thing. So this is for addition, subtraction, multiplication and division. Next, if addition of reciprocals are 1 by C equal to 1 by A plus 1 by C. In this case, how we are going to do? Then delta C by C square in this. Delta A by A square plus delta B by B square. Then delta C is C square into delta A by A square plus delta B by B square. This one will be helpful whenever they give two resistors. R1 is equal to 10 plus or minus 0.1 ohm. R2 is equal to 20 plus or minus 0.4 ohms. Like this, they are going to give. At the time, how to find when two resistors connected in parallel, 1 by Rp is equal to 1 by R1 plus 1 by R2. So delta Rp by Rp is equal to delta R1 by R1 square plus delta R2 by R2 square. So relative error if they ask, delta Rp by Rp. So Rp into delta R1 by R1 square plus delta R2 by R2 square. So this is the formula for relative error. At the time, you should do like this, isn't it? So all these we have given individually 10 minutes videos for us. You can follow those. This is one shot we are doing. Therefore, we are giving briefly about how we have to solve the problems. So now we will see vernier calipers and screw gauge. For this mainly least count. What is the least count of any device means? The least value measured by the device. If you are taking normal scale, between normal scale 0 and 1, how many divisions will be available means 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divisions are going to be available. Therefore, so one least value is going to be this. This is going to be 1 mm or 0.1 centimeter they are going to be giving. So this is nothing but calibration of scale. Between 0 and 1, 10 divisions. What is the each division means? 1 by 10. If 20 divisions are there, each division is 1 by 20. So 1 by 2 is 0.5 by 10, 0.05 centimeters. This is 0.1 centimeters if they are going to give scale like this. Same like this on vernier calipers. We will be having two scales. One is main scale, another one is vernier scale. How these two are going to be divided? So one means the least count formula or value for this. Least count value, two values or two formulas will be there. Two values means one value only with the two formulas. 1 MSD minus 1 VSD. This is one formula. Another one is 1 MSD by number of vernier scale divisions. So they will give, whenever they are giving problems, 1 MSD or n MSD or 9 main scale divisions equal to 10 vernier scale divisions. Each MSD value 1 mm. What is the least count they will ask? At the time, we will use this formula. So 1 MSD value they gave, therefore we will eliminate 1 VSD by using this. 1 VSD equal to 9 by 10 MSD. Then from this formula, least count equal to 1 MSD minus, what is 1 VSD? 9 by 10 MSD. So 1 by 10 MSD. What is MSD value they gave? 1 mm. Therefore 1 by 10 into 1 mm. So 0.1 mm, 0.01 centimeters. So by using this, how to take reading? How we will take reading means reading formula MSR plus VC into least count. So VC means vernier coincidence, LC means least count, MSR means main scale reading. How to take main scale reading we will see. So if we are taking values like this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is main scale, let us say. So on the main scale, vernier scale is going to be crossing, let us assume this value. This is the 0 on Vernier scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this it will be there. Now, 0 on Vernier scale is crossing how much value means this is going to be 1.4. So, that is going to be MSR. Otherwise, they will give. So, 0 on Vernier scale is in between 1.4 and 1.5. Then how much value you have to take MSR means MSR is nothing but how much value 0 is going to cross on main scale. And Vernier coincidence, among all this one value is going to be coinciding, that is this one we are taking. So 1, 2, 3, 4, this is. So Vernier scale is going to be, Vernier coincidence is going to be 4, this is 1.4. So least count value is 0.01 centimeters. So for normal scale 0.1, for Vernier caliper 0.01, which is most precise value means 0.01. So this is how to take reading, and if error is there, how to solve error. So 0 on main scale is exactly coinciding with 0 on Vernier scale, then there is no error. If 0 is right side means positive error, correction will be negative. If this 0 is left side, then negative error, correction is going to be positive. For this we are going to either add it or subtract it. So when error will be coming means whenever there is no object, you will take the error. This is about Vernier calipers. Next, last one in this, screw gauge. So what is the screw gauge least count formula means pitch by number of head scale divisions. In this also two scales. So pitch scale and head scale or circular scale. Next, pitch formula. So distance covered on pitch scale by number of rotations. And reading formula, PSR plus HSR into LC. This is for no error. If error is there, PSR plus CHSR into LC. If error is going to be present. So CHSR means corrected head scale reading. So how to calculate this pitch or number of rotations? So on the index line, you will be having like this value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. On the circular scale will be there like this. For one rotation, it will be moving like this. For two rotations, it will be going here. For 5 rotations, it will be going here. So for 5 rotations, how much distance it is covering? 5 mm. So pitch is going to be 5 mm by 5 rotations. For 2 rotations, 2 mm by 2. Finally, pitch is going to be 1 mm for this screw gauge. Now 1 mm by total number of head scale divisions. For normal screw gauge, circular divisions will be 100. Therefore, 0.01 mm, 0.001 centimeters. Now, which is the most precise value out of normal scale? Vernier caliper screw gauge means 0.1 centimeter for normal scale, 0.01 centimeter for Vernier calipers. Now, this is for screw gauge. Therefore, this is the most precise value. How to take reading PSR? How to take reading PSR means how much value it is going to be visible. Let us assume here it is there, which is head scale. Then how much is visible here? This is 0, this is 7. Therefore, 0.7 mm. 0.7 mm is the PSR. Now, what is the least count means? For normal screw gauge, this is the least count. How to take corrected HSR, HSR? HSR means out of these values on circular scale, some value 25, 30, 20. Then what is the head scale reading means? With index line, how much value is crossing means coinciding, that is nothing but head scale. When you have to take corrected head scale means if you know the error. How to take error means if 0 is exactly coinciding, 0 on head scale is exactly coinciding 0 on in a means horizontal line on index line or pitch scale, horizontal line on pitch scale or index line or reference line. So exactly coinciding means this is going to be no error. So if 0 is below the index line, so let us assume 5 divisions below the index line, then error is going to be positive. How much positive? 5 divisions positive. Therefore, correction is going to be negative. Minus 5 you have to do for 25. If 0 is below, whenever there is no object. If 0 is above, if 0 is above the index line, 5 lines, then error is going to be negative, correction is going to be positive. So plus 5 you have to do for 25, that is corrected head scale reading. So this is about formula for reading of the screw gauge. If you want in detail, already we have given 10 minutes videos or 15 minutes videos. So in this we have given total information. I hope you people got revision. Thank you.